Anyone have questions they want to lead off with? Hints on breadth first search. Besides the hint I already gave. So I assume you all will get better presentations. Yes, Ron, we'll be working with them a lot more on pretty much all of your daily code challenges. They will play an important role. So you'll get a lot more exposure to them and you'll get pretty comfortable working with them. So for breadth first, I'm assuming you already saw the hint I gave on using a queue. We can maybe write out some pseudocode then. Let's pull up a REPL. Okay, so hints on the breadth first search. So first off, we already know initialize the queue, data structure. And this will be important. I'll explain why it's important in a bit. Maybe some of you guys are seeing this hint and are like, you don't really understand why a queue is actually necessary, but I can talk about that in a bit. So first thing I want to do is enqueue the current node. Oops. Okay. Enqueue the current node, and then you'll want to, well, I think the best way to do it is inside of a while loop, while queue is not empty. Then what you'll want to do is a dequeue from the queue. So we're grabbing the element in the queue that was passed in first, and then you'll want to check if this node has children, both left and right sides. If so, enqueue its children, and then I mean, all that's left at that point is to just call the callback with the dequeued node. Okay, so that's the pseudocode for what you're going to want to do for the breadth first search. And so if we go about and let me see, I want to pull up a visual, find one real quick. Nope, not there. Sorry guys, my dog was excited. Oh man, I'm on the wrong account. One sec. Sorry guys, I need to go close the door. He's being awfully yappy today. No, he's really chill and calm. I wonder what the slides. Here we go. So I just wanted to pull up the slides I used for the lecture, but I was also on the wrong account. So I had to go and log out and then log into the correct account. All this for stinking binary search tree visual. Okay. And I want to annotate. So let's imagine that we're at the root node, right? So we start off at 25 and we're going through the logic for the breadth first search. We initialize a queue, okay? So we put this node inside of a queue. So we have 25 when we first enqueue this element. And then we go and check its children to see if they exist. And then if they do, we enqueue these. So just assuming you check the left side first, we get 20. So that gets added to the queue. And the 36 also gets added to the queue. And then, oh, oops, sorry, I messed up a little bit. Let me start over. Okay, so initialize the queue in queue 25. So that goes in. And then the first thing inside of our while loop, where we're doing a check to see if the queue is empty. It's not empty because it has 25 inside. Then the first thing we do is we dequeue the current element, the first element. So 25 gets dequeued. Then we check for its children, 20 and 36. So then those get added. So at this point, the only elements in our queue are 20 and 36, right? Because 25 has gotten dequeued as the first part of our while loop. And then we run the callback on 25. And now our queue is just 20 and 36. And then our while loop does its next iteration, checks our queue, sees that it's not empty because we have 20 and 36 inside. And so it dequeues 20, checks for its children 10 and 22 here, and then adds those 10 and 22. Adds those in, runs the callback, and then 20 is now is out of the queue now because it got dequeued, right? Does that kind of make sense? Can you see how, because we're using a queue now, it lets us to traverse the ordering in a different in the breadth first fashion? So now we go to our next while loop iteration. 36 comes out. Add its children, 30 and 40. So yeah, you see how we're traversing the binary search tree now in this kind of ordering, left to right, by using a queue versus a stack, which was used for depth first search. Does that kind of make sense? You guys want to see the pseudo code again? Oops, get rid of this. Okay, hopefully that clears up any questions about the breadth first search here. But yeah, it's definitely not intuitive at first to just like look at what breadth first search is asking for and come to the conclusion that you need to use a queue. Yeah, that one's a bit tricky to figure out. Any other questions? That's it. I guess in that case, let me do a quick. Is there a type of database where you store data like this? Let me think about that. Hold on, I'm gonna give you guys a little poll just to gauge the progress so far. Oops. All right, there's a poll, and then each number represents, I guess, how many you've completed. So if you answer 6, that means you're done. 3. Okay. Jerome, as to your question, I don't think you would think about it so much as, let me see. Okay, so yeah, there are databases that organize their data in different fashions. So when we later get around to talking about databases, you'll see like when we talk about non-SQL versus relational versus non-relational databases. You'll see that non-relational databases, like for example MongoDB, CouchDB, a lot of the document-based databases store their data as in JSON format, right? And JSON is JavaScript object notation, which is pretty much saying the format with which we'll store the data is as is Thompson in here? That'd be kind of funny. Anyway, he could totally speak to this better than I could probably. Yeah, so document-based or non-relational databases store their data in the form of JSON, which are just like giant objects, basically. Like they have the exact same format of key value pairs like we see in normal JavaScript objects. And these get like nested pretty far, depending on how complex your data is, blah blah blah. But that's not to actually say that the documents actually have like the functionality of hash tables, though, right? So the way I'm showing it here, like this is just how the data that you put into the database is organized. But that's not to say that this notation, this JSON notation, has the same functionality as a hash table, like as an actual JavaScript object, because it doesn't, because it's just notation. It's a way to just represent your data within the database. So you're not actually storing data structures within, typically you're not storing data structures within databases. The main exception would be arrays, because I think with arrays of data, you can definitely store arrays of data. And then when it comes to, because you can store an array inside of JSON, right? So you can nest arrays within JSON, and then because so with data structures, typically you store data structures in a way, and then they have like methods on top of them with which to perform on that data within the data structure, right? But then databases are simply perform the storage and persisting aspect of it. And so a lot of times the databases don't like slice and dice your data, right? There is then servers that will read data from that database, utilize data structures, and then slice and dice your data from the database. So they'll read from the database and then perform operations on said data using data structures. So it's not so much that you store data structures within databases, if that makes sense. This is asking if the data as it is structured in this assignment is how we would store it in a database. Not really, no. Although, so okay, the three different formats that I'm familiar with and I think are the most mainstream are using JSON with the case of document relate. So then we would only encounter this when we need to use maybe on the client. No, you would use it on the server as well, but then the server would talk to the database. Your database would be living on another server that just houses the database, from which the server that actually performs the computations would read from that database, get the data, and then that server that got the data, that fetched the data, would then use its processors to actually perform operations on said data using data structures. So the three main types, as I was getting to, the three main types of ways that I know of that databases store data is with documents, with JSON, inside of columns and rows, as in the case of SQL. So it's where in that case, it's kind of like spreadsheets. And then, yes, I meant that we would only need to use these while we're using them. So other on client or server. Never when it comes to storing. Right. And you would also very rarely perform actual operations on the client side, because typically that will just slow down your client. And as you all know, as a client, as a user of a client application on your computer, you want those to be as fast as possible. And so you typically don't want to perform any. You want to minimize the total amount of calculations or operations that you perform on the client side as much as possible. So you'd much prefer those to be handled on a server somewhere else in order to maximize the performance of your clients. I keep getting deviated. What I was saying was there are documents with JSON, there are spreadsheet type or matrices like rows and columns with SQL, and then there are graph databases. So those are probably the closest you'll get, Jerome, to actually having data or data structures stored within a database. Let's just pull up the wiki real quick. And so a graph database, it stores your data in the graph structure, and it makes it so that it's optimized for fetching data via the actual connections versus indexing, which is what Mongo and which is what relational and non-relational databases both use. They use indexes typically to fetch data, but the graph databases are much more optimized for handling the different connections. I don't know too much about them. I haven't read up too much. I just mostly know that they exist. So again, this is probably the closest you'll get, Jerome, to actually having a database that stores a data structure in this case. You can do more reading on that if you're curious. Any other questions? How's the graph going, by the way? It's not. I posted a good link to you guys. You should definitely look at that inside of the mini sprint that that you guys looked through for data structures too. If you guys are really that lazy, I can pull that up too. Let's see. God, I printed out the page. Then I think this particular blog post should at least point you guys in one direction or another. Like he runs through some good code here. Might be a bit more complex than you would actually need to implement, but you know, parsing through this code and understanding what it's doing will take you a long way. Still working binary trees. Okay. It's definitely a lot to read through and understand, but at least you'll have somewhere to start instead of not having any idea where to start. Nice. Oh, right. You're just waiting on hints for the breadth first search, or the breadth first for each. Oh. Cool. Oh. Nice. Yay, collaboration. Any last questions before we wrap up in about 6 minutes or so? Can't get the rotations to work right. What are you talking about? That shit's hard. If there are no other questions, if you guys really want some pointers on red black trees, maybe we can do a private Zoom tomorrow or something like that. Because truth be told, that would take way longer than the time we have left. All right, there aren't any more questions then. I think we can wrap up for tonight. I'll see you guys tomorrow. All right, thanks guys.